How much math you need to learn to become a data professional? Hello, my name is Sumesh Shukla, and in this particular video, I'll help you to understand the various topics you need to be aware about before you can become a data professional. But before we start this video, don't forget to check out Scalar's free masterclass on Scalar's event page by leading industry experts. The link is in the description box. In this particular video, we'll be talking about the various topics, and I will be also taking some examples that will make your journey easy in the world of maths. Before we start this video, don't forget to subscribe to our Scalar's YouTube channel. Let's get started. Let's now understand how much math you need to become a data professional. Now please remember, I'm not using the term data scientist or data analyst or business analyst or machine learning engineer, because being a data professional, you need to have certain knowledge of math. And in this particular video, I'll try to explain you how much math and from which topic, which all subtopics you need to prepare so that you can be a very good data professional. So let's first of all understand various categories of data professional. If I try to understand how many data professions we have, the very basic and the very starting point. So let's say if I wanted to be a data professional, the very first thing that I should start with is to be a data analyst. So the very first step is data analyst. A particular person can become a business analyst. So let's say I'm working as a data analyst at Amazon. Now, once I get the knowledge of business, I can start interacting with the business heads, business managers, stakeholders to apply the logic and the learning from the data to the business. And that is what business analysts do. They try to get or extract the insights from the data and try to resolve the business problem. So that is business analyst. While on the other hand, the people who are data analysts, they are more like not working on the analysis side, but they are trying to interact with the data. So they are the first point contact of all the data requirements. Let's say I wanted to fetch my top 10 customers. Now the person data analyst working in your company would be the best person to return you the top 10 customers. But if I have to take a business decision on top of it, you have to reach out to business analyst. The next step in this ladder is being a data scientist. Now, data scientist is that person who try to utilize the data and come up with some complex algorithms, complex models that can start predicting. So business analyst, being a business analyst, you are trying to resolve problem by taking decisions based on the insights that you have derived from the data. But data scientists try to forecast, try to predict what can happen, how we can enhance the performance of a particular business and various other things. So adding more complexity to your current work is going to make you a data scientist. Please remember, with each step that you climb up in this ladder, you are adding more and more business knowledge to your current knowledge of business. So the more knowledge of business and the more familiar you get with the problem solving, it will help you to become a more profound and a more strong data professional. So data analyst, business analyst, data scientist, and then we have multiple other maybe categories or professions. We have ML ops engineer, we have data engineer, and then we have ML manager. Nowadays, you can also find out the position of AI manager, and we have multiple other positions that that you can find out right now in the market. But according to me, these are the three basic positions with which you can start or with which you can enter into this data world. Coming to the actual question, and for which you are watching this video, is how much math you need to become a data professional. Math is very important, and those of you who think that okay, I don't need to learn math, I can become a data scientist or a data analyst just by learning Python, SQL, just by learning some machine learning algorithms, my friend, that is not going to happen. Even if you want to learn any machine learning algorithm, you need maths, because every machine learning algorithm is a mathematical model. It is running on some numbers, because data is all numbers, and wherever there is numbers there is math, so you need math. So let's try to understand how much math and which all topics I need to learn. I'll help you with a flow chart. So when we talk about maths, there are four important topics. Number one, statistics. Number second, linear algebra. Number third, calculus. Number fourth, discrete mathematics. Now, if you if you are listening to these terms for the very first time, don't worry, because we are going to first of all look into the pipeline, and then I will also be taking one example so that it can help you to understand that okay, this is not rocket science, this is something which you already know, but you have to just brush up your basic maths to understand these high terms or maybe high words. So statistics is further divided into various subcategories. Let's understand. We have descriptive, then we have inferential, then we have hypothesis, which is hypothesis testing, followed by regression, and finally time series. So these are the subtopics that a particular data professional has to be clear with when it comes to statistics. Now, descriptive statistics, which is the very basic statistics, or maybe all of you already know about it, it is further divided into two subcategories, which is number one, measures of central tendency. Number second, measures of dispersion. Now we will try to take examples from both measures of central tendency and measures of dispersion. But first of all, let's try to complete this particular tree so that you can have a clear idea regarding how much math you need from all the subtopics. Now let's focus on linear algebra. Linear algebra starts with the concept of matrices and vectors. So number one, matrices and vectors, followed by matrix operations. When we talk about matrices and vectors, it is really important that you are clear with how to operate on matrix. So matrix operations. This is followed by linear equation, and finally optimization. Now when we come to calculus, under calculus we have topics like differentiation, integration. You guys must have learnt about calculus in your 11th class or 12th class. But calculus is also a very important topic when it comes to machine learning. We use calculus, we use a very high amount of calculus when it comes to neural network. Now those of you who wanted to use, let's say those of you who are looking to use neural networks to detect what is the content of the image, or maybe you wanted to use neural networks to find out how each gesture. So let's say if I am doing something like this. Now what is the meaning of this? So we use image processing, we'll use computer vision for this, and while we are working on these applications, we use high amount of calculus. So within calculus we need to be clear with differential, which is basically differentiation, as well as partial differentiation. We also need to be clear with the optimization technique that comes under calculus. Now finally is discrete mathematics. In discrete mathematics, we have the very utilized, or maybe the most important topic when it comes to playing with numbers. If you wanted to play with numbers, discrete mathematics is something that you need to be clear with and you need to be confident with. The reason is discrete mathematics consists of topics like Combinatorics, which is permutation and combination. The next thing is graph theory, followed by probability theory, and finally set theory. This is everything. Like those of you who are thinking that okay, I can become a data scientist just by mugging up, or maybe just by having a very good coding knowledge, having a very good knowledge about various algorithms and how to apply those algorithms in Python. This is the reality. This much math you need to be aware about so that you can become a very strong data professional. Now let's try to understand each component. Like when I talk about descriptive statistics, what exactly is it? When I talk about matrix, what is that? When I talk about differentiation, what is that? So I'll take a example from each of this category so that you can get a little sense about what exactly you will be learning if you take one particular topic. So let's understand. Now let's start with measures of central tendency, which is basically the part of descriptive statistics. You guys already know about it, but let me just help you with the basic understanding of it so that you can start your journey in descriptive statistics and you can enjoy it. So descriptive stats, and the very first topic is measures of central tendency. Now, measures of central tendency is something that can help you to find out the center point of a data. Measures of central tendency are basically your mean, median, and mode. Mean is also known as average. Let's try to understand it. Let's say I'm having the data regarding, let's say, the marketing budget. Or let's change the example, let's make it more realistic and something which you guys can easily understand. Let's say this is my years of experience, and in y-axis I'm having salary. Now let's create some data points. First of all, let's define the axis. So this is years of experience as 0, 1, 2, 3, 4, and so on. Here I'm having, let's say, 100, 200, 300, 400, 500. Now let's create some data points. So for 0 years of experience, I'm having a data point over here. For 1, I'm having, let's say, a data point over here. For 2, I'm having over here, 3, then 4. Now this is the data that I'm having. If I try to find out a middle point that can help me to get one value that represents this complete data, then that value is known as mean. How to calculate mean or average? It is given as sum of all the observations divided by total number of observations. So here I'm having observations like I'm having, let's say this is 150, comma, I'm having another one which is below this. So let's say this is 110, comma, this is, let's say, 250, comma, let's say this one is again 250, and then we have a point 400. So these are my data points. Let's add them. So is equal to 150 plus 110 plus 250 plus 250 plus 400 divided by 1, 2, 3, 4, 5. So you will get 500, 900, 1000, 1200. So this will come out to be 1160. We have to divide it by 5, and if you do the calculation, it will be 232. Now if I try to point this particular data in my graph, so 232 would be less than 50, so somewhere around here, and I'll create a line for this. Now this is my average line. So here you can see that it is basically the center point of the data, where you can see that I am having approximately half data points above it, half data points below this. So average defines the center of the data, and that is the reason it is a part of measures of central tendency. But there is one problem with average. Average is influenced by outliers. Now what is outlier? Let's say I am having one particular employee whose salary is around, so the person is having experience of 5 years, but the salary is somewhere around here, and this salary is, let's say, 2000. With very less years, the person is still having a salary of 2000, while other people are having a salary in a range of 100 to 500. Maximum is 400. Now what will happen if I try to calculate the average? So now the data points would be 150 plus 110 plus 250 plus 250 plus 400 plus 2000 divided by 6. So previously the summation was 1160, I will add 2000 to this, 2 divided by 6, so this will be 3160 divided by 6, so you will get 526 point something. Now here you can see that just because of this particular number, which we call it as outlier, your average salary has been shifted to somewhere over here. And this is not the center point. This is your average line with outlier. And this is not the center of the data. So that is the problem with average. Your average as a measure of central tendency is influenced by outlier. Influenced by outliers. Now how to get rid of them? That is the reason we have median. If I try to calculate the median with the same data, so median is basically the center point or central point in the data. No matter if you have outliers, if you do not have outlier, it will be always center. So when I say center, let's say this is 0, this is 100, so your center will be 50. So your 50% of the data will be below this point, 50% data, while your rest 50% will be above this point, 50% data. That is what your median is. If I have to find the median for any given data, step number 1 is sort the data or order the data in ascending order. So order the data in ascending order. So I'll get 110 followed by 150 followed by 250, 250 followed by 400 followed by 2000. Now I'll take the middle value. Here the middle value is basically this, because below this point I'm having 3 data points, which is 50% of my data. Above this point I'm having 3 data points, which is 50%. But how to find out this middle value? If my data is having odd number of data points, I'll directly get the middle value. But if you are having even number, that is simply the average of these two values. Average. So 250 plus 250 divided by 2, you will again get 250. And this is my average. So you can see that even this particular data is having outlier, which is 2000, which is this value, is still my average is 250, which is near to center. So my average is over here. This is my average line or the median line. This is my median line. Median line. Now what is mode? So we have understood mean, we have understood median. What is mode? Mode is that observation which is having highest frequency in your data. So the particular observation, mode is the observation with highest frequency in the data. Highest frequency means most number of occurrence. So if I look into my data, and I should add 2000 also in this, the particular value, which is 250, has occurred for 2 times, while other values like 150, 110 and 400 and 2000, they have just occurred for 1 more time. So my mode would be 250 in this case. This is my mode. So you can understand that all these measures, which are the measures of central tendency, are basically helping you to find out the central point of the data. While mean is a metric that get influenced by the outlier, median is is still a metric which is not getting influenced by the outlier. Another advantage of median is that it will give you a point in the data from where below that point you will have 50% of the data, above that point you will have 50% of the data. Now let's try to understand measures of dispersion. Measures of dispersion. Now my objective is to find out how far the data points are from the central point. So let's say if I'm having a particular number line and this is the center of the data, and I'm having data points which are very far away over here. So remember, this is my center of the data while these are my data points. So here you can see that your data points are very far away from the center of the data. So it will have high dispersion. While if I'm having this case where this is my center and data points are concentrated around the center. So these are my data points. Now this kind of data is known as with low dispersion. Now the metric that can help us to calculate this is known as the measures of dispersion. We have various metric around this, but two basic metrics are variance and standard deviation. Let's try to understand it by performing a calculation on Excel. So here I'm having my Excel data with years of experience and salary. Now let's first of all find out the average, which is nothing but mean. So mean, we will apply the formula, is equal to average. I'll find out the average salary. Or let's use years of experience because that is more simple to understand. So average years of experience, so is equal to average, and I'll select my data range. So this is my average, which is 5.31. Basically mean the central point of the data is 5. You have some employees below this, you have some employees above this. So maybe we have some employees with 1 year of experience, we have some with 15 also, but this is the center. Similarly, let's find median, is equal to median, and we will use the same data range, and that's 4.7. And let's find mode now, is equal to mode, and my mode is 3.2. Now you can see that these three values are not equal to each other, they are different. One thing we can understand is the data must be having some outlier due to which this particular thing or mean and median is not matching. Also mode is not matching. If a particular data is having mean is equal to median is equal to mode, then the data is balanced, which basically means it is exactly having the center point 50% below, 50% above. This kind of data is known as the normal distribution data, which is difficult to find out in reality. But our objective is to understand variance over here. So let's come to the point. Now what we will do, we will find out the distance of this point from the average. So from the center, how much far years this particular employee is. So the average or the middle point is 5.3. This particular employee is having a year of 1.1 and the difference is 4.2. So let's calculate that difference. So I'll write DIFF, which is difference, is equal to average minus the value, and I'll fixate the average value and press enter. Now this is 4.2. Let's apply the formula to all the rows. Now here you can see that I am having some positive values, some negative values. If I wanted to find out on an average how much the value is above or below the mean, I need to take the average of this column, right? But if I take the average, my positive values will cancel out negative value. So that is a problem, right? The easiest solution is we take the square of these values. So diff hyphen square. And let's take the square of each value. So this value to the power of 2. And I'll expand the formula to all the rows. And now we'll take the average of all these values. So is equal to average of all these values. And here the average is 7.7, which basically means, now this is something which is wrong, because remember we have taken the average of squared values. So this is also a square value. How we can get a actual answer to understand how much a particular data point on an average is above or below the central point? I'll take the square root of this value. So is equal to square root of this value, and that is 2.7, which basically means on an average a particular data point is 2.7 units above or below the mean, and that is the standard deviation of the data. Now higher this number, the data is having higher variance. Lower this number, the data is, or maybe most of the data points are concentrated towards or around the mean. Remember this particular number that we have derived, this is known as variance. And variance is something that is hard to interpret. That is the reason we use standard deviation. We have direct formula to calculate these numbers in Excel also. For variance we have VAR over here, and it will give you the exact same answer, which is 8.5. Now there is a difference. The difference is because of degree of freedom. Please do not worry about this particular concept as of now. It's again a mathematical topic, but as of now I'll delete this. Let's summarize what is standard deviation and what is variance. So standard deviation will help you to understand how much a particular value, or how much on an average the values are below or above the mean, and that is 2.79 in this particular case. Now let's try to understand the second category, which is linear algebra, and the most important topic under linear algebra is matrix. Now I hope everyone knows that the data with which we work, it is a two-dimensional data. We have rows, columns, and the best way to represent that data is using matrix. Now when you have a matrix, you have to perform a variety of operations like multiply the matrix, transpose the matrix, find the inverse of the matrix, and so on. Let's try to understand some basic operations in matrix. So a particular matrix is a 2D structure defined by rows and columns. So here we have rows. So these are my rows, row 1, row 2, row 3, and these are my columns. Column 1, column 2, column 3, and these are my elements. A particular matrix can have variety of shape. The shape of a matrix is defined by the number of rows followed by number of columns. So this matrix is having a shape of 3 cross 3 because it is having 3 rows and 3 columns. Now when you have two matrices, there are certain rules that you have to keep in mind before performing matrix multiplication. Matrix multiplication. The very first rule is the number of columns of the first matrix should be equal to the number of rows of the second matrix. When you multiply two matrices, the output that you will get will have the number of rows equals to first matrix and number of columns equal to second matrix. Let's take one general example. Let's say I'm having a matrix with 1, 2, 3, 4, 5, 6. And here I'm having a matrix with 2, 2. Now this is my matrix A. This is my matrix B. Can we perform matrix multiplication? The answer is no. These two matrices cannot be multiplied because the number of columns of first matrix should be same as number of rows of the second matrix. So what we have to do, let's add one more value. So let me make this as 2, 2 and 2. So this is now 3 rows, 1 column. Now this is matching this, so we can perform matrix multiplication. How the matrix multiplication will happen? Remember, R will be multiplied by C. Rows multiplied by column. So this is my one row. I'll multiply this with my entire column. Let's do that. So my first value will be 1 into 2 plus 2 into 2 plus 3 into 2. My second value will be 4 into 2 plus 5 into 2 plus 6 into 2. And that's the answer would be 2 plus 4 plus 6. 2 plus 4 plus 6, and this will be 8 plus 10 plus I think 12. So here the total is 12 and here the total is 30. This is your answer. Now the number of rows, this is for the resultant matrix after multiplication. Resultant matrix after multiplication. So the number of rows equal to first matrix. We have 2 rows which is equal to first matrix. Number of columns equal to second. Number of column is 1. So 2 comma 1. And this is my answer. So I hope now you guys are clear with how matrix multiplication happen and what is exactly a matrix. Again, we are not covering up everything in this video, but I'm trying to help you guys with the essence of each topic that you have to learn in detail when it comes to mathematics required for data professional. So let's move to the next topic now. Now let's try to understand the differential, which is differentiation and partial differentiation. I will give you the idea regarding how to perform differentiation. So let's say I'm having a function f of x is equal to x square. Now why I call this as a function? Because assume that it is a machine which takes input as x and returns output as x square. So this is a function of x. This is my input to the function. This is my output to the function, and this is function of x. So that's how we call it, function of x. Now if I have to differentiate this function, then we use the term dy by dx of f of x. Here also we will apply dy by dx of x square. There is a general formula of differentiation, which is dy by dx of x to the power n is nx n minus 1. That's the general formula. So this will return me 2x 2 minus 1, which is 2x. So the differentiation or the differenced value of the function x square is 2x. In machine learning, we call this as the slope. So when you differentiate it, you get a slope. And now we are not going to talk more about what is slope and what is machine learning, or maybe which algorithm I am talking about right now. But this is what differentiation is, and you have to learn this topic in detail. How to perform differentiation, the chain rule. I'm just putting the topic name over here, the chain rule, which basically mean if I do not have the function, which is this, as one particular element. Let's say I'm having a function f of x is equal to x plus y plus 2x square, let's say. Then how we can differentiate this? There is a chain rule that will help you to differentiate this, and this is really important for any person who is trying to enter into machine learning. So this is the topic that you should be clear with when it comes to differentials. Let's try to now proceed with the last topic, which is combinations and permutations. Combinations. This is a very important topic when it comes to sampling. Combinations and permutations are something which we generally apply in real life also. But when it comes to machine learning, or even not machine learning, when it comes to data science, when it comes to general data analysis, combinations and permutations are really useful to find out how many iterations or how many times I have to perform a certain task, or how many possible variations are possible in this given data. Let's take one example to understand the difference between combinations and permutations. So let's start with combination first of all. So combinations talks about the number of ways to select a particular data point from a given data. Let's try to understand this with one simple example. Let's say I'm having a population. So this is my population with 1000 people, and I wanted to sample out 100 people. Now, how many combinations are possible? Like, which all 100 people should I select? So how many possible ways are there? Let's try to calculate it. The formula for combination is given as NCR is equal to n factorial divided by r factorial, n minus r factorial. Now what is n? N is the total number of observation. R is the selection that you are trying to make, which is 100. Let's apply the formula. 1000 factorial divided by 100 factorial. 1000 minus 100 is 900 factorial. If you wanted to expand a factorial, it will be, so if I expand 5 factorial, it will be 5 into 4 into 3 into 2 into 1, which is 5 times 4 is 20, 60 and 120. Similarly, if I try to solve this, 1000 factorial divided by 100 into 900 factorial, you will get 7.53 into 10 to the power 16. Now these many combinations are possible. These many combinations, these many ways you can select 100 people from the group of 1000 people. And it is a good way to understand like at what scale we are going to work on, or maybe how much efforts we have to put while performing a certain task. So combinations are of great use when it comes to data science. Let's try to understand permutation also. Permutations. Now in combinations we are trying to understand the various ways. In permutation we are trying to understand the arrangement. Let's take one general example. So let's say I'm having 5 books A, B, C, D, E. Now how many ways are there in which I can arrange these books in the shelf? So should I keep A first followed by B, C, D, E? So this is one combination. Sorry, this is one permutation. Similarly, if I place B first followed by A, C, D, E, this is permutation number 2. Similarly, if I keep C first followed by A, B, D, E, this is permutation number 3. So how many such permutations are possible? So for this we have a formula NPR, which is n factorial upon n minus r factorial. So here n is the number of objects, which is 5, and r is the number of places, which is again 5 in this case. So 5 factorial divided by 5 minus 5 factorial. This will give me 5 factorial, which is 5 into 4 into 3 into 2 into 1, which is 120. So there are 120 possible ways in which you can arrange these books in your bookshelf. Now that is what permutation is. So I hope now you guys are clear with how much math you need to be prepared with if you are looking to enter into the field of data science, or maybe trying to become a data professional. Again, in this particular video, I have tried to make you understand the importance of each and every branch of mathematics. We have not covered everything in detail, but I hope that I was helpful enough to give you the starting point for each of the topic. So that was it for this video. Now I hope you guys know what all topics you need to start with to become a data professional. Before we end this video, don't forget to give this video a big thumbs up, share this video with your friends, and don't forget to subscribe to our Scalers YouTube channel. I'll see you in the next video. Good luck.